Next up, we'll see one of my favorite new features in JavaScript, async functions. So async functions and this entire section depends extremely heavily on promises. Make sure that you are comfortable with promises, and if you're not, go through the previous, I think 2 sections ago, the promises section, because at their core, async functions are just a nice syntactical sugar for promises. It's a nice, clean, easy syntax to work with promises, but you still have to understand promises. All right, so let's start with a quick intro to the main idea behind async functions. If we have some regular old function, let's call it getData. And getData makes a request using Axios. I already have Axios included. Or we could use fetch or even an XHR if we are a bit psycho. Let's do axios.get. I have a URL. It doesn't matter, we're not building anything with this, but I'm fetching some information using Axios. In a regular function, if I tried to console.log something afterwards, let's say I wanted a variable called data, and I want to set it equal to the result of running axios.get, this URL, and then console.log data. What will we see when I run getData? Okay, let's try it out. It's not going to work to give us the data. All that we see is a promise. Okay, so axios.get returned a promise, and we console.log that promise. The promise was pending. Now it's hopefully resolved, but it doesn't matter. We don't have access to that resolved value anyway, because we're not waiting. We're not using .then, as we've seen with promises, in order to run code when the promise is resolved. So it would be nice if we could write code like this, where we could just write one line and act as if JavaScript was synchronous, meaning that this code would not run until this finished. But instead, we've got to do this, .then, as we've seen, data, and then we console.log data. So we'll see our first console.log of data, which should print out a promise. If I run it, there we go. And then we see what we get back. So nothing new here, just reiterating the fact that we can't write code like this where we expect this thing to be done first. If we have code that relies on an asynchronous operation, like an axios.get method call, we need to use .then, assuming it returns a promise, which axios.get does. Otherwise, we would pass in a callback. So this is nothing new. This does not work. But it would be nice if it did, right? It's kind of obnoxious that we have to worry about callbacks and .then. And that is the entire point of the async and await keywords. So there are 2 new keywords, 2 pieces to making this work, 2 pieces of the puzzle. And by the end of this section, you'll see how we could write a function that looks pretty much like this, with no .then, really no explicit mention of promises or callbacks, and the function will look like it's a synchronous function. Like this happens first, and then as soon as it finishes, this runs. But behind the scenes, there will be promises involved and .thens and promises being resolved, thanks to the magic, the syntactical sugar of async and await. So that's the whole goal. It doesn't give us anything we can't already do with promises. It just makes it easier and cleaner to work with promises and create synchronous looking asynchronous code. So let's see how it works in the next video. We'll start with the async keyword. All right, so there are 2 pieces, async and await, 2 separate keywords. We're going to start with async. So we use async in front of a function declaration or function expression. We use it to designate a certain function as an async function. And the key thing to understand about this keyword is when you put it in front of a function, like I have here, this function behaves differently. It's now going to return a promise. So even though I never write new promise, I don't explicitly say, hey, return a promise. I'm simply saying return a string. Because I put async there, the function now returns a promise. And I can show this to you. Let's make a simple function. We'll just call it greet. Function greet console.log. Actually, that's not console.log. Let's return hello. Okay, no surprise. If I call greet right now, it's not an async function. We get a string back. JavaScript 101, return a string, we get a string. Now, if I duplicate this and put the async keyword in front of my function declaration, now when I call greet, what I get is a promise that was returned and resolved with the value of hello. So whatever the value that I'm returning is, the promise that will be returned from greet will be resolved with that value. So I could do something like greet.then, and we'll just call this val. And then we can console.log promise resolved with, and then we can add in val. So I can chain on a .then because greet is now going to return a promise. Test it out. There we go. Promise resolved with hello. Let's say we have another function. This one will be trivial as well. Let's go with add, and it takes in x and y. It returns the sum of x plus y. Right now, if we don't make it async, it just returns a number, assuming we pass in two numbers. If we make it async by putting the async keyword first, if I call add, we get a resolved promise with the value that it's resolved with set to 9. So I could use a .then. These two simple functions make kind of no sense at all to use promises with or to make async because they're not doing anything asynchronous. Why use a promise? But the next thing I want to mention is, how do we return a promise that is not resolved? So if things go well, we return a value, return the string hello. That promise returned from greet is going to be resolved with hello, or with the number 9. In this case, if we add 4 and 5. But sometimes we want to make promises where they might be rejected, they might be resolved. And inside of an async function, if we want to return a rejected promise, all that we do is raise an exception. So if we throw an exception, we throw an error, that promise will be rejected. So if we use this add example, let's check if x and y are actually numbers. If they're not, we'll throw some sort of exception. So we could just check if x, let's do type of x equals number, or if it's not equal to number, let's do that, or type of y is not equal to number. Then we can throw x and y must be numbers. Okay, so let's not make this an async function for a moment, just a regular old function. If we run it and I call add with e and I don't know, 5, there we go, uncaught exception, x and y must be numbers. So the logic works, no promises involved whatsoever. We call it with numbers instead, everything's good. Now if I make it async, try it again, add 4 and 5, we have a return value. This code was running, and so the promise is resolved with that return value. If I call it with a string, something that's not a number, we still get a promise back, but it's been rejected. X and y must be numbers. So I could call add on e and r, sure. I can put on my .then. Let's go with val, console.log. Why don't I just copy this here? Promise resolved with val. And I could put a catch as well. And promise rejected with. And then we'll print the error. So I'm just calling add, but add is an async function, which means it returns a promise. It may be rejected, it may be resolved. I can handle it either way. And if we take a look, I run my code, we get promise rejected with x and y must be numbers. So at this point, async functions are, with what we've seen, they're a nice way of returning a promise. Take a moment and think of how you would write this yourself. So without using an async function, but by manually creating the promise and resolving/rejecting it. Here's what I would do. It would look something like this, function add x comma y. Then we would return a new promise. We have our resolve function parameter and reject. And if none of this looks familiar to you, make sure you check out the promises section. I can't say that enough. It really helps. So we have our new promise, and then in here, we can move this logic, but we're going to change it a bit. If type of x is not a number or type of y is not a number, instead of throwing, we're going to reject the promise. Like that. And then here, we would resolve with x plus y. So if I comment out my async version, and we take a look at our manual promise creation, it's called add, this code should still work fine. So I should be catching this error, the rejected promise, and we get the same output. If I instead do two numbers, like, I don't know why I keep doing 4 and 5. How about 6 and 7? Refresh. Promise resolved with 13. All right. So an async function on one level is just a shortcut syntax to make a function that returns a promise. If you return a value, like we do here, that value will be the value the promise is resolved with. If you throw an exception, instead that promise will be rejected with this value. So our .then callback or our .catch callbacks still work. But this is not all there is to async functions. That is the async keyword, and shortly we'll see the await keyword, which makes things even more magical. Next up, we move on to part 2, the second keyword, await. So we have async, which we use to declare an async function. It basically is a fancy way of wrapping that function in a promise. But await is really magical. We put the await keyword inside of an async function, and it will pause the execution of the function while it waits for a promise to be resolved. So it will await something without having to use a .next. We can run code after an asynchronous operation without having to nest things with callbacks. So here's an example. Let's use Axios, which I already have included. We'll just do the same old dumb planets API from Swappy. And I have Axios, as you can see here. We have axios.get. That returns a promise. Instead of returning a promise myself from a function, let's call this getPlanets, return axios.get, like that, and then doing getPlanets.then. Let's say I want to console.log the planets after the fact. So getPlanets.then res console.log res.data. So hopefully this works. No async function involved. There we go. We get the data. So we return a promise, then we have to use .then and wait until the callback is actually executed and our code gets broken up. It's a little harder to read. It's still much better than passing in a bunch of callbacks to a function since we're using promises. But the easier way is to declare an async function, getPlanets. We'll do our axios.get, pass in the URL, and the craziest part right here is await axios.get. And we'll save the value that the promise is resolved with to a variable. I'll call this res. And then I'll put a line after here, console.log res.data. Same thing I had here. So this looks like it's synchronous. This is going to happen. It doesn't matter how long it takes. We'll get some response value. We'll call it res. Then this will run after that promise is resolved, only after it's resolved. So we don't have to use .then. It looks like a nice, cute, synchronous function. One thing happens, it finishes, the next thing happens, and it finishes, and that is what the await keyword does. But let's verify that it actually does. So let's do getPlanets, refresh over here. Awesome. So this returns a promise, as we've seen before. If I just run it over here, we get, whoops, copied the wrong part. If I just run the axios.get, that returns a promise. Normally, without awaits, we console.log res.data will get an error. Oh, well, we don't get an error. We get undefined. There is no data property because this is a promise that is returned and it's not yet resolved when this runs. But by putting await here, JavaScript will wait. It will not move on until this promise is resolved. So the promise will be resolved. That value it's resolved with, that's normally passed to .then, will just be stored in this variable. And then we have access to it on the very next line. It's important to know, though, you can only use await inside of an async function. This will not work. I get a nice error. Await is a reserved word. I cannot do it unless I'm in an async function. So even for just one single request, like we have here, this is still much easier to read. We don't have to do .then. We don't need an extra callback. It's not horrible to do .then and to work with promises, but this is so nice, right? It's just syntactic sugar, so it still uses promises behind the scenes. It just kind of hides it from you and it makes it look synchronous, but it's still easier to read. It's easier to write. And as you'll see, when we start making more requests or doing more asynchronous operations, it's very easy to see what happens first, then second, and third, and so on. So we'll get some more practice. All right. So this is great, very short and easy way to wait for an asynchronous operation to complete before running the next line. But what if the asynchronous operation, if that promise is not resolved? What if it's rejected? Right now, it's working out. I have internet. I'm not requesting an invalid URL. But if I change that, this endpoint should give me a 404. Axios is going to reject the promise. I don't have a catch. I don't have any sort of error handling. What happens? Let's see. Uncaught in promise, error, request. I don't have any code that I'm running either to catch that error, maybe to make a different request, to tell the user something went wrong. I am not handling it at all. We have a couple of options. The first is to chain on a .catch to my getPlanets call. Remember, getPlanets is an async function. It returns a promise. If I catch getPlanets, error, console.log in catch, and then let's console.log the error as well. Let's see what happens now. Okay, there we go. In catch, here's my error. I caught it. We have another option though. If you don't want to have to use .catch and pass in a callback, you can comment that out. In my async function, I'll keep this original one, I can add a try and catch block, which looks like this. Try something, otherwise catch the error. So here's what I would want to try. And if something goes wrong, if an exception is raised, if there's an error, don't freak out, just run this code. And I'll console.log in catch, comma, error, E, not error. Let's see what happens now. I need to call getPlanets still. GetPlanets. Great, let's try it out. Same output. Well, we said in catch. I think, what did we have before? In catch with 3 exclamation points. This time we have 1. So we get the same behavior, but these are technically different. They're different because this is going to catch any errors, any issues within this one async function. Here, I could have multiple functions that are returning promises. I could have .thens, and as we've seen before, the callback in our .catch will run for any of them if the promise is rejected. So when we have one function we're calling, it doesn't really matter. We're just doing one thing. There's one place, one promise where the error could be raised. So it's not a big difference, but there is a difference. This is more of a backup to catch multiple potential errors. Here, it's more specific to what we're trying to do, and we can be more detailed in how we handled it. But I'm not going to deal with that right now. Next, what I'd like to show you is how we can make multiple requests or multiple asynchronous operations in a single async function using await and async. Async await. Welcome back. Next, we'll get a bit more practice with async and await. So I'm using code that I wrote back in the promises section. I know I've said this in pretty much every video so far in this async section, but if you did not watch the promises section, highly recommend you go back and check it out, or at least look at the code in more detail. Remember that everything we're seeing here with async and await, it's all promises underneath or behind the scenes. It's just a little wallpaper on top, or makeup on top, or paint, or who knows. It's something on top to decorate it, to make it nice and pretty. So this function that we created a couple sections ago is called moveX. MoveX returns a promise. And in this promise, it will move an element a certain number of pixels horizontally or along the x-axis, left or right, depending on the number you pass in, positive or negative. And then it uses a delay. So it waits 1 second or 3 seconds before it actually does that operation. So it returns a promise, set timeout with a delay. I'm using 1 second for all of them. And then it moves some element that number of pixels using transform, unless we don't have enough room to keep moving. So at that point, the promise is rejected. If we do have enough room, the element is moved and the promise is resolved. So we end up with something like this. If I shrink my window down, we can move a couple times, and then the promise is rejected. We caught it with our catch down here, and we console.logged some information about the error. This is what we had before, this massive mess of callbacks, success and failure callbacks. Promises really helped us clean it up. Now we'll see how we can continue to clean it up using async functions. we won't have to write any of these .thens. So what we'll start with is calling moveX. I guess I'll just comment this out. We'll keep the button. We do need that. I'll duplicate it just so we have a record of the original. We need to select the button, and we'll call moveX, but I'm going to do it from inside an async function. So I'll call this function, how about animate right? It's not really a nice animation because it's so choppy, but we'll call it animate right. We'll make it an async function, and we'll pass in an element. Then inside of here, we will call moveX, which returns a promise. I'll pass in that element. I'll pass in an amount. So let's just hard code this as 100 pixels at a time every second, 1000 milliseconds. This returns a promise, so I can await it. And if I want to wait for this to finish before I run the next moveX, I don't need .then. I can just await this first one and then do it again. Fingers crossed, hopefully we move twice, as long as we pass in the correct button to animate right. So we'll call animate right btn. Refresh. 1 jump, 2 jump. Awesome. So if we wanted to move this many times, we could do the exact same thing. We just duplicate this every time and we await. We say wait until that promise that is returned from moveX has been resolved. And if it's resolved, then move on to the next one. However, right now we're not catching any errors, so if we do hit that boundary and the promise is rejected, you'll see we get an error. We'll take a look. Good. It's waiting every time for that promise to be resolved, and then boom, uncaught error. We did not catch this anywhere. We just talked about how we can catch errors. We could add a try catch in our function. What I would probably do is right here, just add a .catch for that error, and then we could just console.log, all done. Let's see if it works. Okay, continue. Awesome, and all done. Perfect. Okay, so if we take a look at this, compared to what we had here, I mean, it's not a massive improvement. We don't have to write all the .thens. We don't need these unnecessary callbacks anymore, which I think is definitely worth it. And all we have to do is add in await and async. Now this is relatively simple logic we're doing. It's not much logic at all. It's the same thing every time. So it maybe isn't as clear. But when we talk about making sequential requests, which is what we'll see next, making Axios or fetch requests one after another where they depend on each other, using async await makes it much easier to read and understand what's going on, not to mention shorter. So why don't we wrap this up? Instead of just animating to the right, why don't we also, once we hit the end, animate back to the left? So we could change this animate right to accept an amount, and then anytime I'm passing in 100 there, I'll replace it with amount. And then here, when we get that error, when we've hit the edge, why don't we console.log and move the other direction? So console.log, all done, and then we can call animate right, same element, btn. This time, here we need to say we're moving 100 pixels. This time let's move negative 100 pixels. Let's see if that works. So we move to the right, and we're going to hit that edge. We get all done, and now we're moving back to the left. Now we don't really have any error handling for the left side, so we're just going to keep moving off the screen because our logic right now in animate or in moveX is just checking the right boundary. So I guess that's a bit of an oversight. But we now have this async function here that we can call. It returns a promise. Within it, we can await any other thing that returns a promise and mimic synchronous code. So next, we'll see how we can do this with requests. How can we have sequential requests? And we'll also talk about parallel requests, which is another way of sending multiple requests where we don't have to wait for one to come back first. Next up, I'd like to talk about an important distinction that has to do with using await within an async function. So to illustrate this concept, which I haven't even mentioned yet, I'm going to use Axios again to make some requests asynchronously. It takes time. We'll use an async function. We will await the request. I have async, I have Axios included. And we're going to work with a different API this time, another free API, pokeyAPI.co. If we go to the endpoint API/v2/Pokemon, and then we pass in a Pokemon number like 1, we get a ton of information about that Pokemon. So let's request a couple different Pokemon. I'm just going to copy that URL. We'll do something like axios.get Pokemon/1, and let's make sure that we create an async function to help us. Instead of having to add a .then, we get a promise back. So we'll make our async function get, how about 3 Pokemon. So we'll move that in there. We will await, save that to a variable. We'll call this it looks like poke1. So we've got that. We're awaiting it. Now, if I just want to verify everything worked, why don't we console.log poke1.data. Go to my page, refresh. Oh, I'm never calling my function. What a moron. Get 3 Pokemon. Try again. Okay, so now we get a ton of data about that one Pokemon. Where is name? Is name not even included on here? There we go, Bulbasaur. I should know that. Bulbasaur, Pokemon 1. So if I wanted to also request 3 other Pokemon, I could do something like this. Pokemon 2 equals await axios.get Pokemon/2. This could be Pokemon/3. Make sure I use the correct name. And then we can console.log Pokemon 1, 2, and 3.data. So we're awaiting each one. We're going to make this request. When it's finished, we get something back. If it's resolved, we keep moving on. We're not catching any errors, but I assume these are going to work. My internet's up, the API's up. And there we go. It looks like it's pretty much instantaneous anyway, but it's important to note they are happening in sequence. So this has to finish completely before this. So this runs, we get data back, then this line runs, we get data back, then this line. So they're not going in parallel. They're not being sent off at the same time, like 3 carrier pigeons, I think is what I mean to say. 3 pigeons or Harry Potter owls in the night with their own letters and packages. No, it's one going and returning. Then the second owl leaves and returns. The third owl leaves and returns. They are in sequence. And this isn't a huge deal for something like this, although we don't need them to be in sequence because these don't depend on one another. We're not using information from this first request to make our second request. We could, if I wanted to get some URL from the response, the actual data we get back. I think, is there something instead of species? Here we go. Species has its own URL. I could request that. We've got forms. Yeah, I guess there's a URL there. And then each ability has its own URL to get more information about. So I could send a request to this URL, for example, and it would have to be in sequence. We couldn't send them off at the exact same time because we're waiting for the first request to come back before we make the second request. But here, they have nothing to do with one another. They are independent endpoints. They're not related, other than the fact that they're with the same API. We're not depending on this one first in order to make this one. So we can rewrite this to have our requests go in parallel. I'm going to duplicate this. I'll just write sequential requests. And then this one will be parallel. I'm not going to await. I'll get rid of those awaits here. I still need to await at some point, but I'm not awaiting there. Then down here, I can await Poke1, await Poke2, and await Poke3. So this may not seem like a big distinction, but it is. As far as the way these are actually happening behind the scenes, it's a pretty massive difference. So here we're not using await anymore when we actually send off the request, like we were here. So this means that we're sending off the request, it returns a promise, so Poke1 will contain a promise. If I were to console.log it here, console.log Poke1, refresh, we see that we get a promise here and it's pending at this point. All 3 of them are probably pending unless it's an incredibly fast request, which is highly unlikely that it's going to beat JavaScript speed. By the time it gets to this line, they probably won't be back. But then we're saying, all right, await the response that comes back, await the response, await the response. But the requests are being sent roughly at the same time. I mean, as fast as JavaScript can send them off, or the browser can send them off. Versus here, we're fully waiting for this response to come back from the request. We're waiting for the promise to be resolved before we move on. Same thing here. So I'm going to illustrate the difference with something that is slower so you can see it in just a moment. But let's make sure we can actually use the data. Right now, what I have will not work. Await Poke1, await Poke2, await Poke3. We are awaiting the promises. We're making sure they're resolved, but Poke1.data does not exist. Poke1 is the promise. If I look at what I got printed out, 3 undefineds. Undefined, undefined, undefined. Up here, Poke1, Poke2, and Poke3 are not the promises. This is a promise, but when you put await there, it waits for a resolved value and stores that resolved value in the variable. So Poke1 is an actual response. It's the value we get back. Here, Poke1 is a promise. So Poke1 should be resolved by the end, but it doesn't actually have, it's not a variable storing the value. So we could do this. Maybe promise1, just give them a different name, prom2, prom3, and then we can await prom1, 2, and 3 and save those to variables. So we would do something like this. Const poke1, I need to change those numbers, 2 and 3 equals await that promise, await this promise, await that promise. So the 3 requests are sent off independently. They're not in a sequence. They're not depending on one finishing before the next sends. They go off on their own into the night. They come back. We are awaiting for a resolved value. That resolved value will then be stored in Poke1, 2, and 3. Fingers crossed. Cannot access Poke1 before initialization. Oh, yes, we changed the name. If we look at prom1, it's a pending promise. Then down here, if I were to look at prom1 again for some reason, console.log prom1, it was pending. Now it's resolved. The value it was resolved with is this object. This object here that is stored inside of Poke1 now. So the promise was not resolved. It was pending. Now it's resolved because we awaited it. Then we have access to all 3 of those pieces of data. We can do something with them. So these were sent in parallel, which is a big distinction if you do not care that one request must be finished before the next is done. But in a case like this, it doesn't matter. It's better to do them in parallel. So now let me illustrate the difference for you. And I'm also going to show you another way to clean this up so we don't have to have all these variable names. But first, I'll show you a much easier to see visualization of the difference between awaiting in sequence versus awaiting in parallel. These responses or the requests are coming back so lightning quick that it's actually almost impossible to see with your own eye that they are slower if we do them in sequence versus parallel. It just happens in a split second. They all show up at once. So I'm going to do something slower. Let's make a function called change body color, which will accept a color and a delay. It will return a promise. And after this delay, it will change the body color. So our promise is going to have our resolve, reject parameters, standard stuff. Then we'll have a set timeout where we have a function to run after a delay. So that delay will be passed in. So I would call this like change body color to teal after 1 second. So that will be 1 second there, set timeout. After that 1 second is up, we will set document.body.style.background color to equal color. And then I'll resolve the promise. I won't worry about rejecting it. I guess we could reject if someone passes in a non-color or an ugly color, but we won't bother. It's not really the point of this demo. So let's make sure it works. After 1 second, hopefully the body changes to teal. There we go. Okay, so now let's make an async function, and we'll call this one light show. And all we're going to do is call change body color and await that. Then we'll do it again. Change body color to pink after 1,000 milliseconds. We'll call light show and see what happens. So async, await this promise when it's resolved, then move on to this line. So we go to teal after a second, and then pink. Okay, so I'll add a couple more colors here. Let's see, teal, pink, how about indigo, and violet. So right now, these are happening in sequence. The first thing finishes, then the second, then the third, then the fourth, which is probably what we would want. But if these were requests taking 1 second and they are not related, we may not want that, which is what we saw up here. So now let's see how this would work in parallel. I'll comment out this version. In parallel, I would save each of these to a variable. So I'm just going to select all of those and save it to a variable, or I could put them in an array. I'll show you something called promise.all in the next video. I'll just go with P, 1, 2, and 3. I don't know the shortcut to do those numbers easily, so I have to manually type them. Okay, and then we'll do await P1, await P2, await P3, and P is just standing for promise, so await P4. What do you think we'll see? So all 4 of these functions are going to run roughly at the same time. This one will run first, then this one, then this one. They all take a second, and they change the background color, and they resolve that promise that is returned. So we await them down here, rather than waiting for the full second to be up to then run to the next one. These will happen pretty much at the same time. So this is what we see. 1 second, straight to, what was the last color? Violet. We don't see those pauses along the way. So this took only 1 second, maybe a little tiny bit more than 1 second. This took 4+ seconds. Very different. And here we get a different light show effect. This is probably more desirable. If either of them is at all desirable, this is more interesting. But with requests, if you don't need them to happen in sequence, do it in parallel. It makes way more sense to just have them go at the same time and await all of them at the end. Speaking of which, I'll show you an even simpler way of doing that in the next and final video in the section coming up after this. I think this is a good place to stop. So we saw how we can make requests in sequence, which is useful when you need one thing to come back before the next, especially if they are dependent. You're trying to use some data from the first request to then send off your second, which I wasn't. So then I showed you doing it in parallel, where you don't await them at the same time that you are actually creating the promise and sending that request off. Instead, you send the request off, you await them afterwards. And then we saw an illustration of visually the difference using this light show function. Okay, so next I'm going to show you one last tweak and we'll be done with async functions. All right, the last thing we'll take a look at is a nice and clean way of what we did here, sending requests in parallel and just waiting until they were all back before we did something. This code down here won't run until we have a resolved value from this first promise, second one, and third one. But the requests are still being sent at roughly the same time. So if I don't want to have to type all of this stuff, it's kind of annoying having to make these different variables. What we can do is use a promise helper method called promise with a capital P .all. And promise.all accepts an array of promises. So these are all promises that we get back. So I could just pass those in to promise.all, prom1, prom2, prom3, and then await that. I could call this const results equals await promise.all. I'll get rid of the original one. Now let's take a look at results afterwards, console.log results. Thanks to the magic of async functions and await, I can just write it directly beneath, even though this may take a while. If my internet sucks, if the internet's not on, or if the API is down, I'm not catching the errors, but we could also do that as we've seen earlier, so I won't spend time on that. So this is much cleaner than what we had before, assuming it works. Let's make sure it does. I refresh. This is what we get back. Another array containing 3 response objects, which is the values that those promises are returned with, thanks to Axios. So if I was awaiting something else, I would get whatever the resolved values were in a results array. So this returns a promise itself. This promise is resolved when its own promises in this array are all resolved. Then we're awaiting promise.all to be resolved, take that resolved value, it's now stored in results, and then we move on. As soon as this is done, this code runs. So then we could print out something for each one. How about just make a separate function, print Pokemon, and pass in results. Then I can just define a regular function called print Pokemon. It doesn't need to be async. This will be passed results. So in here, I would just do for let Pokemon of results. And we want the data dot, I think it's name. Why don't we just do that? Data dot name. Console.log data dot name. Pokemon dot data dot name. Let's test it out. There we go. Bulbasaur, Ivysaur, Venusaur. So not the most useful actual request that we're making, but this is much nicer than what we had before, where we were awaiting each promise individually. Await prom1, await prom2, await prom3. Here, we put them in an array, and then we can await that entire promise.all, and then move on. This code will only run when all of these promises have been resolved. So that's kind of it for async functions. We use async to declare the function as an async function, and then we use await to await a resolved value within an async function. We can't use await outside of an async function, only inside, but the combination of the two helps us write code that looks like it is synchronous, but it still is behaving asynchronously. It's just much easier to read. Remember, it's all built on top of promises, and it's just syntactic sugar. So we'll get tons of practice later in the project portion of this course. We'll work with Axios and make a lot of requests and write our own async functions and use await inside. Alrighty.